And about me, myself, I'm Ashok, working as assistant professor, senior skill, specialization is production engineering, and has 18 years of experience in teaching. And about the course, for this course has 5 units. Unit 1 is casting, Unit 2 metal forming, Unit 3 is metal joining, Unit 4 and 5 are about metal cutting process. Unit 4 about lathe, drilling and grinding. Unit 5 is about milling and CNC. Unit 1 casting. So outcomes of Unit 1. So the course outcome is explain the operational and procedural steps required for manufacturing a cast part. So at the end of this course, you will be able to explain the operational and procedural steps required for manufacturing a part made of casting process. And this ZO course outcome is divided into 3 LOs, learning outcomes. The first learning outcome is compare and contrast different disposable mold casting process. Disposable means it's been thrown out, it's been broken out. And the specific outcomes of LO1, there are 3 specific outcomes: SO1, SO2, SO3. SO1 is illustrate hand casting process, SO2 illustrate lost wax casting process, SO3 is illustrate cell mold casting process. And learning outcome 2, compare and contrast different non-disposable mold casting process, which is permanent mold casting process. For this is being divided into 3 specific outcomes. First outcome is illustrate die casting process, SO2 is illustrate centrifugal casting process, and SO3 is illustrate continuous casting process. And the final learning outcome LO3 is distinguish different types of casting defects. So these are all the outcomes of Unit 1. And foundry. So foundry is a factory in which molten metal is poured into molds to produce cast metal objects. So basically casting is melting a metal, pouring into a mold cavity to produce the component, and this is done in a factory called foundry. And there are various examples of cast objects. The simplest example is the iron box, the one that we are seeing in the figure here, and the alloy wheel, and big components like engine block, and very huge components like turbine plate. So for casting is used to produce very small object to huge objects. And casting, as I told you already, casting is the process in which molten metal is poured into a cavity and it is allowed to cool, and which produces the required shape. So this is casting process. And the steps in casting process: melt the metal, pour it into a mold cavity, and allow it to freeze. So once it freezes, you will get the required component. And the final component is also called as the casting. So the product that is made out of casting process is also called casting. And capabilities and advantages of casting. So advantages are it can produce complex part geometries that cannot be made by any other process, and it can create both external and internal shapes. Intricate shapes can be produced using casting process. And almost all the processes are near net shape process, casting process. Near net shape is you can produce the exact final shape. So that is possible with the casting process. And it can produce very large parts, as I have told you already, that jet engine blades. And some casting methods are suited to mass production. So you can do mass production with certain casting process, and you can also apply it for plastics and ceramics. Apart from metals, can be applied to polymers and ceramics. And classification of metal casting process. So metal casting process classified into 2 broad category. One is expandable mold process. The other one is permanent mold process. That's what we've already seen in the learning outcome. Disposable, non-disposable. That is expandable is disposable. Mold is destroyed to remove part. The advantage is more complex shape can be produced. And the disadvantage with the expandable mold process is production rate is limited, because you have to produce the mold and using a pattern, and once the mold is ready you can pour. So this is the disadvantage with the expandable mold process. In permanent mold process, mold is made of metal and can be reused. Advantage is higher production rate. The disadvantage with mold permanent mold process, geometry is limited by the need to open the mold. If you have to open the mold to get the component out. Therefore, you can produce a component geometry which allows the mold to be opened. And types of casting process. First, expandable mold process. You have sand casting process, cell mold casting process, investment casting process. So these three processes comes under expandable mold process, which is disposable mold process. In the second category, permanent mold process. Under this you have die casting process, centrifugal casting, and continuous casting process. So we will see all these 6 processes under unit 1. So first we'll start with sand casting. So about sand casting, this is the most widely used sand casting process. All alloys can be sand cast, including steel, nickel, titanium, and parts ranging from small component to very huge component can be produced using a sand casting process. And production quantity, you can produce one quantity to millions of quantity, and this is the advantage of a sand casting process. When you go for a permanent mold casting process, producing one component is uneconomical. But with the sand casting process, you can even produce one component. And this is the process flow of sand casting process. So the first process in sand casting is making a pattern. So first initially you have to produce a pattern. And once you have made a pattern is the replica of the component. So if you have to produce a mobile phone, so you need to have a pattern which looks exactly same as the mobile phone. Or if you have to produce a casing, the pattern should look exactly similar to the casing. And once the pattern is made, the pattern can be made in using wood or a metal, aluminum. And once the pattern is made, the next process is mold making. So to make a mold, we need to prepare molding sand. So molding sand has to be properly prepared, mixing with clay, moisture, and once that mold sand is prepared, and using the molding tools, you can produce a mold. And if required, you can also go for core making. So cores are used to produce hollow components in the hollow things in the component. And once mold is ready, the next process is pouring. So pouring is melting the metal and pouring into the cavity. So for that you require a raw material, and that is to melt, and that molten metal has to be poured into the mold cavity. And once it is poured, the next step is solidification and cooling. So once it is fully solidified, it is cooled, the next process is removal of sand mold. Break open the mold, we will get the finished casting. Casting is the final component, and that has to be cleaned and inspected. So this is the process flow of a sand casting process. And this figure represents a sand casting process, and is actually a cross section through a mold, where you can see there are 2 boxes, drag, cope, which are generally called as the molding flask. The molding flask, the lower one is called the drag, the upper one is called the cope. And you can see the mold, the blue colored one is at the middle is the mold cavity, and the yellow color is the core. The core is used to produce hollow component. So if core is made of core sand, and that is kept inside the mold. So once you pour the molten metal into through the pouring cup, so it flows through the down sprue and through the runner into the mold cavity. So once it fills the mold cavity, you can fill only the available space, and some of the space is occupied by the core, for that will be left hollow. So that is the purpose of a core. So this is about overview of sand casting process. We will see in detail in next slides. So various tools used in sand casting process. The first is the box, the molding flask. As I told you already, there are, if it is 2 boxes, the lower one is called the drag, the upper one is called the cope. So if it has 3 boxes, the lower one is drag, the middle one is cheek, the upper one is called the cope. So this is about molding flask. And next, the other tools are shovel and trowels. So shovel is the tool which is used to mix the sand. with the clay and with the water. And trowels are used to take the molding sand and pour it into the cope or drag boxes. Then rammers. So rammers are used for compacting the sand. Once you have poured the molding sand into the boxes, for the sand is compacted using rammer. And the next tool is strike off bar. Strike off bar is used to remove excess sand from the top of the cope and drag boxes. Once it is filled, excess sand is removed using strike off bar. The next tool is vent wire. So vent wire is used to make holes randomly at places so that gases can escape easily. Otherwise, there will be a defect in the casting. So vent wire is used to make vent holes so that gases can escape easily. And sprue pin. Sprue pin, you have two riser and runner. Runner is used to pour molten metal into the cavity, and riser to have extra material so that they can compensate certification. The next tool is the gate cutter. Gate cutter is used to make the connect the runner down sprue and to the mold cavity, and that is you have to make a gating system, and that gating system is done using this gate cutter. Next tools are bellows and mallet. So bellows used to blow air, as you might have seen in a smithy shop or where they produce knives and all. They will be using bellows to blow air. So that smaller bellow is used to blow air to remove sand particles from the mold cavity. And mallet, and that is used to just a hammer. A wooden hammer is called a mallet. I'll tell you why mallet is used next. Okay. And this is the process flow, how actually sand casting process is done. And first is mixing of sand, that is using with shovel. Mixed with sand is mixed with the clay and binder, and the coal dust is also mixed. That the coal dust is used to improve surfaceness. And the first, once you have made the sand, next step is invert the drag box. Drag box has to be initially inverted, and at the middle you have to place the pattern. Once pattern is placed, then the second step is pour the molding sand, and it has to be compacted. Pouring, you will use the trowels, and for compacting you will use rammer. The next step, you have to invert again. The drag box has to be inverted again, and the cope box has to be placed above. So now cope box is placed. Then the cope box has to be filled with sand. Before that, we have to insert the sprue pin, the runner and riser at appropriate locations. Runner just slightly away from the pattern, and riser directly above the pattern. And this cope box is also to be filled with the sand and has to be compacted. So compaction is done by rammer. The next step, take the cope box, you have to remove the cope box, and you have to remove the pattern. So to remove the pattern, use a draw spike, and that draw spike is inserted into the pattern using the mallet. So that's why mallets are used. And once the pattern is removed, the boxes are closed again so that you will get a cavity with a pouring hole. For pouring hole is obtained because of removal of the sprue pin. Then next step is pouring, the actual casting process. For molten metal is carried in a ladle, and that is poured into the mold cavity through the runner hole. And once it is fully filled, you have to wait for the metal to cool. Cooling will take place many hours to days depending upon the size of the casting. So this completes the sand casting process.